Assalamualaikum bachcho. So today the topic that we'll be doing is atoms, molecules, and stoichiometry. It is a relatively easier topic. You have already done this in O levels, I believe. So now just carrying on from there, but just a bit more detail and some special keywords to focus on. Nothing more. So let's understand what is a relative isotopic mass. What is a relative isotopic mass? No, what is an isotope? But what is an isotope? We have just studied isotope is an atom, right? So if I were to find the individual mass of an atom, individual relative mass of an atom, that is called a relative isotopic mass. A very common example is chlorine that we have already done in O levels. There are two different isotopes of chlorine that exist, chlorine 35 and chlorine 37. So the mass 35 of chlorine individual atom is called the relative isotopic mass. Similarly, the mass of chlorine 37 is called the relative isotopic mass of chlorine 37. Now, this is a relative mass. It has no units whatsoever. I cannot say that there is a unit to it. Ye grams mein hai, kg mein, nothing right now. We're just calling it a relative mass. So what is it relative to? Kis cheez se relative hai ye? The relative point is carbon. There is a scale, mass spectrometry mein thoda aur detail mein we go through this, but there is a scale on which we'll say that a carbon 12 atom has a mass of exactly 12 units. उस स्केल के हिसाब से every atom का mass हम देखते हैं and we figure it out. Yes, आसानी से मैं ये कह सकता हूँ it is the sum of the protons and the neutrons in an atom. That is absolutely right. But फिर that won't be doing justice to the actual concept. तो relative mass को समझो. There is a scale, हमने उस पर कार्बन 12 का एटम का मास देखा, that came out to be 12.0000. तो we said अब ये इतना छोटे डेसिमल्स में जा रहा है, so can I round it off to exactly 12? फिर उसको डिवाइड बाय 12 कर लिया because carbon has 6 protons and 6 neutrons. उस हिसाब से हमने कहा that it is proton has a relative mass 1 and neutron has a relative mass 1. So we can just add up the protons and neutrons to get relative isotopic mass. Relative isotopic mass is mass of an atom. Is this clear? So mass of individual atoms को हम relative isotopic mass कहते हैं. If you want, you can write down this definition. It is the mass of an isotope or an atom on a scale on which carbon 12 atom has a mass of exactly 12 units. When we do mass spectrometry, we'll cover this part in detail. Is this clear, bache? Moving on, the next thing is relative atomic mass. Now, the words are very confusing, but we need to be cautious about it. Relative isotopic mass is mass of individual atoms. But relative atomic mass is not mass of individual atoms. What is relative atomic mass? You are right. It is the mass. It is the average mass of an atom. I'll give you a very easy example. If I have a class and every student gets a mark which is an integer, किसी को हो सकता है 50 में से 30 आए, किसी के 48 आए, किसी के 37 आए, किसी के 42 आए, किसी के 45 आए, किसी के 46 आए. Everyone is getting their individual marks. And if I tell you that the average of the class is 37.6, अब किसी बच्चे के 37.6 मार्क्स थे? नहीं थे, क्योंकि हर बच्चे को तो राउंड ऑफ सर आपने नंबर दिए. But 37.6 is the average mass of the entire class. और कैसे निकाला आपने? आपने पूरी क्लास में देखा कितने बच्चे हैं, सबके मार्क्स ऐड किया, यू डिवाइडेड बाय द नंबर ऑफ स्टूडेंट्स. तो क्लास का जो एवरेज मार्क होता है वो जरूरी नहीं है किसी बच्चे का नंबर हो. इट वाज जस्ट एन एवरेज व्हिच इज यूज्ड, व्हिच कैन बी यूज्ड टू डिस्क्राइब द एंटायर क्लास. So the same thing is relative atomic mass, because we have atoms of different masses. What do we call them? Atoms of different masses. अभी पढ़ा हमने. Isotopes. Isotopes are atoms of the same element but with different masses. तो isotopes हमारे पास exist करते हैं. They are atoms of the same element with different masses. Now because they have different masses, तो अगर मैं क्लोरीन गैस यूज कर रहा हूँ तो मैं फिर एक इंडिविजुअल क्लोरीन एटम का क्या मास यूज करूंगा? मुझे कैसे पता चलेगा कि it is built of chlorine 35, chlorine 37 or what? So instead of using individual masses when I'm dealing with the entire substance, I try to use their average. Is this clear? The average mass of an atom of a substance is called relative atomic mass. It is not the mass of an individual atom. That is called relative isotopic mass. You can write this down. The relative atomic mass of an element is the weighted average of the masses of its isotopes. Again, this will be dealt in detail with mass spectrometry, how the abundance of each isotope is measured using a mass spectrometer. Right now, I'm just giving you a value. If I'm telling you that for every 3 chlorine 35 atoms, there is a 1 chlorine 37. I'm giving you the ratio and I'm asking you what is the relative atomic mass of chlorine. How do you find it? 35 वाले कितने हैं हमारे पास? 3. 35 plus 35 plus 35, or the easier way to do is 35 into 3 plus 37 वाला एक है. इसको किससे डिवाइड करेंगे? 4 से. So we'll get the average mass of chlorine. 35.5 chlorine के किसी आइटम का मास नहीं है, but this is what we call the relative atomic mass of chlorine. Is this clear? Clear है बच्चे? Anything, any question till now? Okay. Now relative molecular mass. One thing that we have to be careful here is relative molecular mass will only exist for molecules. And what are molecules? Substances that are, when do I get a molecule? When atoms are, yes, you are right, they are combined together. But how are they combined together? They are covalently bonded with each other. When atoms are covalently bonded with each other, that is when we get a molecule. Is this right? So when we actually have a molecule, only then we use the term molecular mass. Is this clear? For example, if I ask you sodium chloride, how does sodium chloride exist? It does not exist as a molecule. It is an ionic substance. So I cannot say molecular mass of sodium chloride. Now we are in A levels, we have to be very cautious about it. Molecular mass, the term itself, even if you are using it in your answer, will only be used if you actually have a molecule, which means that the atoms must be covalently bonded to each other. Is this clear, Bede? So that is relative molecular mass. And how do you find it? You will just add all the relative atomic masses. If I ask you the relative molecular mass of water, so you have 2 hydrogens and you have 1 oxygen, so you get the total relative molecular mass of water, which is 16. Easy. Okay, CHCl3, do it once. Carbon is 12. Figure it out on your own. Carbon is 12, hydrogen is 1. And chlorine is 35.5. This is how we can figure out relative molecular mass, but be very careful to use this term only when you are concerned with molecules. If it's an ionically bonded substance, do not use the term molecular mass. Then what do we use? We use the word relative formula mass. What do we use the word? Now, if you want to find out the relative formula mass for sodium chloride, yes, you can do that. वही NaCl का ही total mass आप निकाल रहे हैं, but you will not call it molecular mass now. Obviously, when we go through the entire topic of bonding, we will understand when do we have molecules and when do we not. We will go through all these. सही है ना बच्चे? So all of this, some part of it we have already done in O levels, and a major part of it we will do in A levels. Is this clear? So now if I ask you the relative formula mass of sodium chloride, the same thing you will do here, which is 23 plus 35.5. Okay, can you find the relative formula mass of the copper sulfate crystal? Okay, Bachi, let's see. This 5H2O, I just told you it means that there are 5 molecules of water per single formula of copper sulfate. So how will we do that? 63.5 is the mass of copper, 32 is the mass of sulfur. I have 4 oxygens, so I'll multiply 4 by 16, and I have 5 molecules of water. So I can easily figure out water is 18, and I'll multiply that by 5. Is this what you're getting? 249.5 is the relative formula mass. Check करो कोई calculation का error होगा, just check it once again. Carrying on from this, how can we define the relative formula mass? You can write this definition down, that it is the mass of substance. It is the weighted average of the masses of the formula units. Whatever is involved in the formula, calculate all of those masses and add them up. Okay. Let's understand the concept of mole. What does mole mean? These are the number of particles that combine to give you 1 mole. How do you need to understand it is very important. If you combine 12 of anything, what is that? What do you call that? Is there a special name when you combine 12 of anything? You call it a dozen, right or wrong? Whether it's 12 chairs, you call it a dozen chairs. Whether it's 12 people, you call it a dozen people, right? If you have 12 bags, you call it a dozen bags, right or wrong? Similarly, when you have these many number of particles, you quantize them as 1 mole. Is this clear or not? If I tell you there is half a dozen chairs, what does that mean? That सारी chairs की आधी हुई है. If all the chairs being half, 6, that is representing a number, right? So similarly, if I ask you half a mole, you must know that it is referring to certain number of particles. Is this clear or not? So if I have these many people somewhere, which I don't think is easily possible, I'll call them a mole of people. Is this clear? So just giving you the reference that it relates to the quantity of a substance. How many are there? कितने हैं? गिन कर बताओ. So that is when we use mole. Is this clear? So now let's understand why this special number. If you gather a mole of water, what does that mean? You gather 6.02 exponent 23. This entire number is called Avogadro's constant or Avogadro number. If you gather Avogadro number of water particles and you place it on the mass balance, it will read you 18 grams. What will it read you? 18 grams. You already know कि सर इसका तो molecular mass भी 18 था. ये तो 1 मोल का mass भी 18 आ गया. That means ये बड़ा अच्छी quantity है. We can use it in future calculations. Is clear? इसलिए the mole is a very important quantity. Example मैं एक और देता हूँ. Sodium का mass is 23. Relative mass, उसका कोई unit नहीं है. But if you gather a mole of sodium particles and you place it on a mass balance, that will read you 23 grams. So that is why such an odd thing. अलग सा जो number है ना, मतलब लोग ये भी कह सकते हैं, you can say सर 1 मोल 1 करोड़ क्यों नहीं होता? 1 अरब particles को 1 मोल बोल लेना, उससे कोई फायदा नहीं है. This particular special number से Avogadro number से we have many advantages that we'll be using. ठीक है? How is that an advantage? 1 mole of 1 mole of any substance will give me the same mass in grams that is its relative mass. जो उसका relative mass है मुझे वो same वही mass in grams दे देगा. Is this clear? So now if I ask you a mass of a mole of any substance, तो जो उसका relative mass है, you'll give me the same value but in grams. Is this clear or not? समझ आ गई बात? Now you can relate it to real life. क्योंकि real life में जब हम measurements करते हैं तो the mass is in grams. Now if I ask you the mass of 1 mole of sodium carbonate crystals, can you calculate it and let me know? Now we have figured out the mass of 1 mole of sodium carbonate crystal, which is 286 grams. Is this clear now? Okay, class. Now it's very easy. If I tell you that 1 mole of sodium carbonate is 286 grams. What if I take half of this, 143 grams? How many mole will that have? Just think and respond. If I halve the mass, मुझे पता है 286 ग्राम के अंदर there are 1 mole of particles. अगर मैं mass ही आधा कर दूं, तो will I get half the mole of particles or not? Same, using the ratio technique, we can figure out the number of moles, which is mass in grams divided by mass of 1 mole in grams. What is the easier way to write it? Number of moles can be written as mass in grams divided by mr/AR. Because numerically it's the same thing. 1 mole का mass वही आता है numerically, which is its relative formula mass or relative atomic mass. Is this clear? So the easier way to write it is number of moles is equals to mass in grams upon mr/AR. Is this clear? So the formula can be rearranged in any way that you want to. Mass mr or AR can be multiplied, cross multiplied to the other side, और इसको rearrange किया जा सकता है in any particular way that you want to. Is this clear? Okay. Again, we have already defined the mole. Okay, class. Now let's understand molecular formula and empirical formula. What is a molecular formula? Again, molecular formula is the formula of a complete molecule. It gives me the total quantity of atoms of particular element that make up that particular molecule. Is this right? What is empirical formula? It is empirical formula is the basic ratio of the elements involved. It is the basic ratio of the elements involved. दो चीजें. पहली बात है molecular formula is specifically used for molecules. Empirical formula can be used for molecules and even for ionically bonded substances. Is this clear? So that is what an empirical formula is. Okay. Example, hydrogen peroxide is H2O2. That means if you take one molecule of hydrogen peroxide, there are 2 hydrogens and 2 oxygens. Hydrogen peroxide has a molecule has 2 hydrogens and 2 oxygens. But if I simplify their ratio, I'll get HO. Right? So this is the empirical formula that for every 1 hydrogen, there is 1 oxygen involved. Is this clear? Now, there is a very easy way of calculating empirical formula. You have done it even in O levels, but we'll redo it in A levels. Let's take this example and try to understand it. From mass data, if I tell you that 0.46 grams of sodium formed 0.78 grams of sodium sulfide. If the name IDE is used, IDE अगर sulfide है, that means it is an ion of a non-metal. सिर्फ sulfur का S-2 का ion है. Is this clear or not? That means that 0.46 gram of some sodium combines with, this was the sodium or total sodium sulfide इतना आया है. So I can subtract both of them and I'll get the mass of sulfur that was involved in the entire compound. दोनों के masses तो मेरे पास है. Remember, what do I need to find? Their molar ratio. साथ साथ करो, do it along with me so that आपको समझ में आ जाए. The first thing is I already know the mass of sodium and sulfur involved. If I divide their masses by their personal AR, relative atomic mass, I'll get each the number of moles of each element that is involved. सोडियम को उसके AR से डिवाइड करूंगा तो मुझे सोडियम के मोल्स पता चल जाएंगे. सल्फर को उसके AR से करूंगा तो मुझे सल्फर के मोल्स पता चल जाएंगे. The AR of sodium is 23 and the AR of sulfur is 32. So basically I'll get their number of moles 0.02 and 0.01. So in order to make it an easy readable number, take the smaller value and divide it by both of them. What do you get? What is the ratio that you get? Okay, minus करके figure out, write down the mass of sulfur. आराम से इसको करो. For every 2 sodium, I have 1 sulfur, right? So the formula of the product formed is Na2S. Is this clear or not? That means for every 2 sodium, I have 1 sulfur. The empirical formula can also be calculated from percentage data. The same thing is provided, but now I'm telling you that for 59% is sodium and 41% is sulfur, and this is percentage by mass. What does this mean? If I take 100 grams of a sample, 100 grams के अंदर there are 59 grams of sodium and 41 grams of sulfur. So assume that you have a sample of 100 grams. You do the entire same thing again. अब मास कितना लोगे सोडियम का 59 ग्राम देखो समझ आ रही है बस. Assume that you have 100 gram of the sample. Sodium's mass can be taken as 59 and sulfur's mass will be taken as 41. Do the entire process again and tell me the formula, empirical formula that you get. Okay, now let's take an example. What if we have a compound that contained only hydrogen and carbon? How will we do that? Same process will be repeated here, but yeah, थोड़ी सी जरा देखकर. When 0.78 grams of a hydrocarbon is a substance that has only carbon and hydrogen, was burned in excess air, 2.64 grams of carbon dioxide and 0.54 grams of water were formed. So if I write a hydrocarbon, I don't know how many carbons are there and I don't know how many hydrogens are there, and it reacts with a certain amount of oxygen to give me carbon dioxide and water. Is this right or wrong? Now understand how and why are we doing the next bit of calculation. The question told us that 0.78 grams of the hydrocarbon. I know the original mass of the hydrocarbon, which is 0.78 grams. And I know that the mass of carbon dioxide produced is this. So can you tell me, if I ask you, can you tell me the number of moles of carbon dioxide? Can you tell me how many moles of carbon dioxide would be there? You know the mass in grams of carbon dioxide? You divide it by its MR, sorry, carbon is 12, plus you have 2 oxygens, which is 16 each. Yes, can you tell me the number of moles of carbon dioxide that you get? I'm doing it a bit lengthy way so that you understand the entire process. Exact. Okay, now understand one thing. When 1 mole of, if there was just one single carbon here, I would have got 1 mole of carbon dioxide. If I'm getting 0.06 moles of carbon dioxide, can I say that the number of moles of carbon, that is also 0.06? Is this right? Similarly, I know the mass of water. Can I find the number of moles of water? Can you do that? You know the mass of water divided by the MR of water. Yes. Zero point zero 0.03. Now, can you tell me the number of moles of hydrogen atoms? If I were to find the moles of hydrogen atom, Can you tell me the number of moles of hydrogen atoms? Understand the relationship. If 1 mole of water were formed, that means there were 2 hydrogen atoms involved, right or wrong? So if I have 0.03 moles of water formed, how many moles of hydrogen atom would be there? I repeat, if 1 mole of water were formed, एग्जाम्पल देता हूँ, if I take a dozen of water molecules, एक दर्जन में water के molecules लाकर आपको दे दूँ. Now every molecule of water has 2 hydrogen atoms, right? आप उसमें से मैं कहूँ हाइड्रोजन जरा गिनकर बताओ, count the number of hydrogen you have. If I give you 12 molecules of water, a dozen of molecules of water, multiply by 2 कर लेंगे आप उसको, right? So if you have the moles of water, can you tell me the moles of hydrogen? You just multiply that by 2. That dozen is a very easy reference point to understand. And again, जब कार्बन और हाइड्रोजन के मोल्स आ गए, remember we were trying to figure out this. सही है ना? दोनों में से smaller number कौन सा है? एक ही जैसे number है, you simplify them and you get the empirical formula of carbon or hydrogen is 1:1, which is CH. Is this clear or not? समझ आ गई बात? Anything that you are unable to understand till this point, please let me know. We'll continue from this in the next class.